Hey, namaste everyone. So this video we're gonna talk about some techniques, some ancient techniques which were used to calculate the area of a circle, which of course many of you when asked to calculate the area of a circle that is shown here with a radius r would say, hey, let's talk about integration. We'll integrate to find out the area of this circle, right? So integration seems to be the way out. But what if I say, even without integration, there were few techniques which ancient mathematicians and artists from Bharat, which you now know as India, used to invoke to calculate the area of a circle. So let's begin. So the very first way to calculate the area of the circle, which they deployed, was the sector way. So what they would do in this particular method is, they would create intersections of sectors from the circle. So they would create as many sectors as possible. Now what they would do in turn is to stack each of these individual sectors in this particular fashion as shown. Now you would see that when you stack these close enough, these sectors would actually form kind of rectangle, right? Well, now imagine that the sectors are not really this huge, okay? They are not really this huge in width. What if I told you that you cut even finer and finer pieces of sectors out of this circle? It means you will have more number of sectors, but each of the sectors will be very limited or very thin in their width. So it would look something like this, right? Each of these individual sectors would be this thin, right? And when you stack them up, it would form literally a rectangle. Here it was close enough to like a rectangle, close enough to be a rectangle, right? But when you actually make these sectors thinner and thinner, you would actually get a rectangle out of it, right? Now, area of this circle would be nothing but the area of this rectangle itself, because it is made up of sections of the same circle, right? What is the area of a rectangle? It is length times width, right? So we literally need to know the value of x and y in order to find the area of the circle. So we have reduced the problem of finding the area of a circle to that of finding the area of this rectangle here, right? Now we need to know what is x and what is y. Well, let's dig into this picture now. So can't you see that x is nothing but this side of the rectangle, which is made up of nothing but circular regions or the curvilinear regions of this sector. Now if you look close enough into this picture, you would find out that half of the curved region of the sectors lies above and the other half lies below, right? These curved regions of the sector are nothing but the portion of circumference of the circle. So combining all the above and below circular regions, you would actually get the circumference of the circle, which is 2 pi r. Now since there are equal number of sectors having the circular region in the bottom and having the circular region on the top, you would actually say that one side of length would be 2 pi r by 2, which is pi r. So this length x is nothing but pi r, and you get this value as pi r. Also, if you see this particular region of the sector, it is nothing but the radius of the circle, right? So the radius of the circle is nothing but the length y, because this region, this portion, this length is what is forming the side of this rectangle here. So this is nothing but equals to r. Now very simply, you will have the area equals to x times y, which is pi r times r, which is pi r squared. And you have the area of this rectangle, which is equivalent to the area of this particular circle. Now let's move on to the second way. The other way of finding the area of the circle was the triangular way, right? And mind you, this was actually deployed by mathematicians and artists. Okay. So what they would do is, they would actually form smaller circles within the whole circle. So this outermost circle is the actual circle. And then what they're doing is they are actually dividing it into smaller circles, which are this white one, this red one, this blue one, this brown one, this yellow one, this green one, right? And what they would say is, hey, take a scissor, cut this, cut this, cut this, cut this, cut all of these circles and then stack them as shown in the figure. Unfold it. Well, once you cut, it can be unfolded into a block like this. Well, it won't really be a block. It would be some kind of a curve. You won't be able to stretch it completely to form a block. But for the time being, let's imagine that it is stretched good enough to form a block like this, okay? So this white one is stacked, and then the red one is cut and stacked, and then the blue one is cut and stacked, and so forth and so on, right? Now, if you cut these circles thinner and thinner enough, if you make all of these circles thinner and thinner enough, you'll have more number of circles to cut, and it can be stacked this way here, right? So as you can see, there is a gap here between all the different circles when stacked up. It is because the circles are too wide enough, okay? So once you cut, their length won't be same. But if you cut thinner and thinner circles out of it, the length will be almost the same, and this width difference will actually decrease, and you will have something like this here when stacked up. So here it is kind of rectangle that is getting formed, but you have these small portions left out. But once you cut thinner and thinner enough circles, this will be an actual rectangle that will be formed, right? Now the area of this rectangle is equivalent to the area of this circle because it is made up of the elements of the same circle, right? What is the area of a rectangle? It is half times base times height. So we literally need to know the base and the height of this particular rectangle. Well, let's see this picture now to find the base and the height of the rectangle, the triangle down below. So what is this length here? This length, as you can see, is nothing but the circumference of the outermost circle, which is the circumference of the actual original circle, right? Because once you cut it and unfold, this is the length which will pop out when stacked up. So this length is nothing but 2 pi r, which is the circumference of the circle. And what is the height? As you can see, the height is nothing but the radius of the circle. Imagine cutting this throughout here, till here. So everything is cut throughout, and this is the stack that is formed once you stack them up after cutting. So this is nothing but radius r of the circle, right? This height is nothing but r of the circle. Therefore, the height of this triangle formed is r. The base is nothing but pi r. 2 pi r. I mean, this was 2 pi r, right? So 2 pi r. And therefore, once you apply it in the formula, you have half times 2 pi r, which is base, times height, which is radius, and you get pi r square. So these were two genuine and innovative methods applied by artists and mathematicians likewise in ancient Bharat to calculate the area of a circle without really using integration as we do today. Well, if you see, it is kind of integration in the sense that you are taking definite number of pieces and making some approximations, and then integrating the stack, and then forming the triangle, and then calculating the area. But anyways, I hope this was cool and you liked it, and you were surprised and overwhelmed at the same time to see these intriguing techniques to calculate the area without the use of calculus. Mind you that this particular technique actually keeps in mind that the circumference of the circle is 2 pi r. So it was known fact that the circumference of the circle is 2 pi r, and then we calculate the area of the circle using this particular fact. In the next videos to come, I'll tell you how ancient Bharatiya people knew that the circumference of the circle is nothing but 2 pi r. Actually, it has a lot to do with the origin of pi itself. Stay tuned for that as well. Thanks. Have a nice one.